with today's daily Leetcode problem. This is code 91 non-decreasing subsequences. Okay, and date is 23. Okay, 20 Jan 23. So you have been given an integer array nums. Okay, you have to return all the different possible decreasing, non-decreasing, sorry, subsequence. Yani you can say increasing or just kind of basically you can just say sorted order. Okay, so you have to return all the different possible sorted order subsequence of the given array with at least two elements. So this is also a condition that you have to have at least two element, because any vector or any subsequence of size 1, it is also sorted, right? So you want at least two size, like 1 and 2 is a correct sorted subsequence that you have to return, and you can return answer in any order, which means like this 467 come at second place, it can come at the last place also, this 77 can come at the second place. Order of this doesn't matter, but order of the thing which you are having, this 467, this is increasing, this is increasing, all these are sorted sequences that you have to return. Okay, also it's not like you have to change the array, it's not like you have to sort the original array, because in this case 44321, there is only one sorted sequence of like length greater than 2, which is 4. Length 1 you have all, but for length 2 there is only one sorted, because this is a decreasing subarray, right? So there is only just one possible subsequence of length 2 which is sorted. So that's what you need to do. It's kind of similar to generate all the possible subsequences, but with some conditions. So that's what we are gonna do. So yeah, that's what I would advise. So basically, the logic for this problem is generate all possible subsequences, which is a pretty standard problem, and I'm going to show you that also. So it's not like that, and just with slight variation, with one variation, that subsequence is to be sorted, should be subsequent should be sorted, and size greater than 1. That's all the two condition that you. So it's more or less this: generate all possible subsequences, right? So let's write code for that. So vector of int for generating one plus possible subsequence, vector of vector int to store all those things, right? Vector of vector int, let's call it v, and we'll pass this to a function called solution function. We'll pass x, we'll pass v, we'll pass nums array, and we'll pass an id index equal to 0. We are starting at index equal to 0. So all the possible, this is the way to generate all the possible subsequences, and at last we'll be returning what is present in the vector. Okay, so this is nothing but all the possible subsequence with a condition, which condition we have to write in solve function, right? So for solve function is not returning anything, it's just filling my v array with the sum of subsequences, right? So while solve and all these things, like what these things, vector of int x, v, nums, something like that. So let's say this is x, you have to fill vector of vector int you want, right? Vector of vector int you want, this is, let's call it v. And also what you want, vector of nums array, basically nums array, I'll call it as a, you can call it any another thing. Also index is being passed, that this is the id which you are current at. So basically this is a kind of a recursive solution. We are moving index by index, so you know how to 4677, let's say we start with index id is equal to 0. So we'll say we have two options, either to take this 4 or not take this 4. We can take this 4, and we can just currently we don't have anything. Currently second option is not take anything, right? Then the second option is to take the 4 and take 6 also, and the second option for leaving on the writing right side, don't take 6, your current sub array subsequence is just only 4. And another way is to now include 6 at the first place, or you should not include 6. So this is a basically kind of a binary tree which will be keep on forming. So 2 raised power n is the time complexity, but yes, constraints are therefore kept very really less. Okay, so that's about it. So now the stopping condition is same, like if id is greater than n, you have to return, not return, basically you can just push into that, right? You can push into that, but you need to check size also. Okay, if id is less than n and greater than or equal to becomes n, something like that, and you need to check if size of this array, if size of x array x dot size is greater than 1, it should be, this is the one condition which we are adding. Otherwise what we do, we generally directly just say v dot push back x, so it push all the subsequence. But now we are just only having, this subsequence of length 1. Also there is one way to write a condition like is sorted, so it's like, okay, so this is the name approach of doing this. Okay, so we are just writing this if condition. Let me just complete this if condition first. Your x should be sorted. Okay, this is also condition given in the question. X dot begin to x dot end. This range should be sorted. Then only you will be pushing back into this. So if I need to create some more space, now there comes the thing. Okay, the logic for generating all the possible sequences is really simple. It's just x dot push back. What I said, just include this element if you want to include it. A of id. Or the another thing is, now if after including, go on the including next element, go on the next index x, v and a. Otherwise what you can do, you can pop this up lcp. Okay, don't include this element, right? So that also what you can do without popping this up. You can just call on solve of id plus 1 without any doing anything, x, v and a, right? So you need to pass this as ampersand, so that, yeah, the reference of this xv and a gets stored. And yeah, because after pushing it, it will come back to the previous state where it was, yeah, something like that. So you have to store the states also. You know what is the, the use of this reference variable. Not going deep into that, but now let's see. N is equal to a dot size. I can keep a dot size. So n is basically the size of the array where you have to stop here. This is your stopping condition. Deadly signal. Why deadly signal? A dot size. Another way to do this is push back x dot pop back, then call the same function. See now, it should work fine. I don't know why it's okay. There is some error which we are doing. Okay, so it can be in v dot push back x dot push back, move to that index, and x dot pop back, come backwards, and then again go vector x v a. This is come generally due to id is greater than this. Okay, so you need to return also, I think. Okay, I think that should be the problem. So now I need to go back to that referencing state. Yeah, because otherwise this will happen. You are storing it. Okay, not just making new vector every time. You're using this memory and storing everything into this. Okay, now here comes the thing. What is this? This is sorted x dot begin x dot end, then only push back. Is this sorted? Yeah, all arrays are sorted, but some duplicates are there. I can see 4 7 7 6 7 7 4 6 double 7. Is that not duplicate? Yeah, 4 6 7 has to be there. 4 6 7 has to be there. 4 6 has to be there. 4 7 7 has to be there. 4 7 has to be there. Yeah, 4 7 again repeating. 6 7 again repeating. Why these 2 3 numbers are repeating again? 7 7. Oh, why the sum of the numbers are repeating again? So there is a method for that as well, right? Oh, okay. There's a method for that as well. You can keep it as set. Okay, currently I'm doing very naive solution. Okay, so this would be affecting your time complexity very greatly, but this is the naive solution, like how you can think out. So there are some repeated subsequence you get. Okay, that's obviously you get if you have repeated elements. So 4 6 7, from this 7 467 from the last 7, that is unique in terms of index but not in terms of value. So they have also said return all the different possible, only different possible, not repeated. So now what you can do, you have set, so set will store unique elements. After that you can convert into vector of vector, so you can paste this your vector of vector int. Let's just create a vector of vector int. Let's create final, its name is final. Okay, so let's make it fin. And what I'm saying, it is just coming out from v dot begin to v dot end. This will store all the elements that are present in set. Okay, and then we can return final. Now it should work absolutely fine. There should not be any problem in it. But this is very naive solution. Will give you okay sorted. Okay, now sorted. It's insert. Insert. We don't push back. We do insert. Yeah. So this is a pretty naive solution of using set. This we can tackle. Now I'm giving the logic for the optimization. This thing we can tackle first. Let's sum this up. This instead of set, perfectly fine submitted, 60% faster. So okay, so no complaints about that also. But still, instead of this, for preventing duplicates, what we can do optimization optimization in solve function. Okay, because why I'm telling this, because solve function you have kept really simple, just of like generating all the possible subsequences. Okay, this is the code for generating all the possible sequences. If you just remove this line, when you push all the vectors, when you push all the, let's say x, this is the all the possible combinations that are possible, all the possible subsequences that are possible. If you'll see, these are the total all the possible subsequence, even the empty one, it is there. So yeah, so you have restricted it with some conditions that your size should be one, your sorted should be sorted, and that's all about it. So that's why it is just inserting that only. Otherwise it will insert all the possible subsequence. Okay, now here comes the thing. Also this was not also not possible all the possible because I used set, so some of the duplicates might get cancelled. Okay, that's we are not talking about. So now I'm telling like how we can do this without set also. So this is obviously accepted. Now let's try to do this without set. Vector, vector, we're returning v only. Now we have to move from this basic thing, take it or not take it, take it then push back into this, and not take it then pop back, and not take it and move forward. Okay, this is the logic for take, not take, forward, move forward. Okay, and then not take, and these two are moving forward. Okay, now we are going to change that. Okay, this can be obviously changed with a decent logic, that currently you're standing at index I, and you are only allowed to take the next indexes only, because you this is the how we are forming a subsequence also. Like it's not like if your array is 1 2 3, 3 to 1 is not a subsequence. Okay, do you get this? So how we are generating subsequence, if you are starting at index 1, so let's say you have taken 1, you can take now 2, or you can skip 2, you can take 3. So you can pick all the indexes after this. So this logic we are going to use. For current index is my id, so I from id at I is less than n, I plus plus, I can take the elements, these elements. But there is a restriction. If that index, that x is empty, or like it should not be equal to previous element. That's what I'm saying basically. you know Now to make sure that this is sorted, the next element which you are taking is either your x is empty, okay, then you can fill anyone at the first place, or otherwise it should be sorted order. So sorted order, how we can get, it's not like I'm gonna write it sorted. It's simply like, if you're that which the current index we are which you are thinking to add should be greater than x dot back, whatever the last element present are there, or it should be greater or equal to will also work, but less than will not work. Okay? If it's greater than or equal to, now we have to uh, make sure how duplicates element are not coming. So there is a logic for that as well. X dot find what this a of id. Repeated element cannot be there. No, repeated element can be there, but that's about it. So x dot find this. How can I say this? Okay, let me think. Okay, so now we were at this point, then we cannot see why 4 comma 6 is not coming. Okay, so let me tell you why 4 comma 6 is not coming due to some reasons. Okay, so first of all, what we are doing, so now we are starting from the fourth index. Okay, we are starting from the first index, which is 4. Then we are saying, like, this to maintain a sorted order. Then we are pushing back into that. Okay, we're pushing back 4 into that, and then we are going on the next index. Okay, now you have taken 4 and then go to next index. If I say like this example way, you have taken 4, now you have to take the next index. Okay, so now it can choose anyone from 6 comma 7 comma 7. Okay, so it can move either to 6. Okay, so now sol plus 1, id is still not greater than 8 of size. It will go into this and it will push 6 or 7 of that, and it will push back that into this, and then move forward, and then move forward, and so on and so on. And x dot pop back, it will also keep on doing. So that's how it is generating. Now the one of the things which we have to do, like, except this, we have to also do one certain thing, which is, now you have to remove this sorted part, because I'm already taking the sorted part according to me, right? So that is the thing. Or also, the thing about this now, when you write this kind of logic, when you do for loop kind of logic for generating subsequence, so there are two logic for generating all the subsequence. One which I just showed you till now, like, which was the taking or not take options, like, during the recursive calls. And the other option is just to do by for loop. Okay, for loop this particular index, you want to take that index or not. So when you do this for loop, you don't have to write this condition if id is greater than a dot sign, because you don't have to reach the last index to, push back into that. You can just push back at any of the index. At any of the index, you can push back whatever you are having in the current uh, x, which is, so you can, if it is having the size greater than 1, you will push back. So now you will see, you will have 4 comma 6. Okay, you will have 6 comma 7, all these things you are having. But now here comes the main idea, here comes the main thing, that there are some repeating elements also. Not repeating elements in case of like 4 6 7 7 7 7 is not repeating, but this 4 6 7 is repeating twice. Why this is repeating twice? This 4 6 7 is repeating twice, and anything else which is 6 7 is repeating twice. This should not, there should be all the distinct subsequence in this, bigger array. Why the subsequence are repeating? Because of this 7 7. It's easy to see, right? Once you took this 4, then you will say that I'm taking this 4, and then I'm taking this 6, and then I have options to take 7 comma 7. I have two options to take, and then you say I include 7. Okay, so I did not took this 7. Some person would say ki, okay, you have 4 and you have 6 and you have two possibilities of choosing 7 7. Don't choose this 7, choose this 7. Okay, so when you include this 7 into this will look something like this, and there is no other thing, you are just at the last index. But these two array look same, even if they are different. In the case like the 7 is coming from the third index, this is coming from the, yeah, fourth index, if you talk one indexing, but still these are same. Okay, so now how to tackle this? So the good thing about this problem is that you need to realize this pretty good, this constraint that you need to realize, this idea you need to realize, that how I'm differentiating this thing. So you are differentiating on based of two things. Okay? These two things are the index which you are at. Okay? Index you are at now. Okay, currently which index you are at, and what's your last element, right? What's your last element? Your last element. On base of these two things, you can differentiate, you can just, check what is going to come next. Okay, let me give you a simple example. Okay, this will trick your mind somewhat. 7 7 7, and there is 8 8 9. Okay, so give me all the possible different subsequence you can generate from this. Okay, 4 to 6, you will, let's say you have added 4 comma 6. Okay, now if you take this 7, okay, you can take this 7, and you say that, okay, I'm not taking these two 7 because you have possibility to do that. You are saying I'm skipping these 7 7. Either you can take it, you can take it also. It's not a restriction, because equal elements are allowed. But after taking the 7, you are saying I'm not taking this 7, so I'm going to this part. Okay, 8 and 9. So this part is, let's say we keep it this part as 8 and 9 as separate part. So now you have only option to choose is from 8 and 9. Okay, so this 7 will go, this 4 6 7 array will go and go to this 8 8 9 and form all the possible subsequence that it can form, which is valid, all valid subsequence, like valid in case of like increasing order, as well as some increasing order size greater than 1, which is already is. So it will form all the possible valid subsequence. But then if you say ki, okay, I'm not including this 7, not including index, let's say 3, it was now index 3. If I'm doing indexing like one base indexing 4 5, so if you include, let's say, 4 index, okay, include index 4. Index 4, which also looks exactly same, 467 and 889, right? You have 8 and 9. Also, you are not obviously including the sixth index, also fifth index, also you are just seeing for this array. So 467 going to this part of subarray and choosing all the possible valid subsequence has already been done. You don't have to do it again. So why, if this was some case like you have choose 4, you have chosen 7, and you have not chosen the 6, then the case would have been different. Okay, so if you are but because in this you are currently your index, let's say you have taken, let's say last element you have taken is 7, and you are how many elements you have taken? You have taken 2 elements in this case. So it's completely different if you are saying that okay, now I'm going to choose 8, 8, 9. But yeah, it's not different from that thing when you have choose just 1 7, 1 4 and 1 7 from, let's say, any other index. Like this 7 is coming from index 3, and this coming 7 is coming from index 4. There is no difference in that if you are just gonna choose again like 889. Right, so you are saying that currently the index which I am present at and my size of the subarray, if this is same, so you have already calculated this thing. So how to store this? We will store this in using something like set, because to check the repetitive element. So now let's now focus on what I'm doing. So I'm choosing an unordered map, or set, sorry. You can just keep a set of integer, or now name it hash set, just to check some hashing values, like just to check that whether this has occurred before or not, or this condition has to be true. So this what condition key hash set should not contain this element previously. Hash set dot find a of I equal to sh dot end. Okay, Phew, that's all what you need to do. And initially, it is obviously not present in this. When you process this, when you process, you are currently standing on index ID. You are processing this all the elements after this. So when you process an element which value is 7, okay, whose value its index can be anything. It can be 3 or 4 or 5, any of these 7, but its value is 7. That is important. So you will say ki hash dot insert 7 has came. If 7 has came, so you will not go to 7, so it is a of I. 7 has came, so next time when you pop back that and you come back and you again go on this, so you say okay, again I'm getting index equal to 4 5 options is are my there, like index 3 के लिए आ रहे हैं. When I run for index 3, it calculated all the possible subsequences, 4 5 7 8 9. When you run for 4, there are no distinct subsequence which you are getting, because 3 के बाद whatever you will do, will be there obviously. And when you do, when you are saying कि I'm not taking this 3, now instead of this I'm going with the 7, and I'm next time taking this 8 and 9. Okay, I'm not saying that I'm taking this next 7. Okay, so that is again same. So you are inserting hash set of I, and this is obviously this is initializing after again every recursive call. So this will get erased completely by itself. You don't have to do that. So it is obviously forming new. If you have formed it in global space, then you have to erase that also. And that's all about it. Now you can just try to sum this up. If the all comments are commented, no, this needs to be there. V a of I hash set dot find a of I. What is he saying? Bracket is missing. If that is present, hash dot find is not equal to hash dot end, which means we should specific x dot empty and y dot end. Yeah, extraneous bracket. So it's correctly submitted. As you can see, this is thing which you have to do. Yeah, bye.